Hello दोस्तों, this is problem number E of at coder DP contest knapsack 2. So in this problem, we have given that and there is n items, there is n number of bags, and it is numbering from 1 to n, from each I greater than 1 to less than equal to n, and each item I has a weight of Wi and a value of Vi. So Taro has decided to choose some of the n items and carry them home in a knapsack. The capacity of knapsack is W, which means that the sum of weight of items taken must be at most W. Find the maximum possible sum of value of items that Taro take homes. So there are some bag B1, B2, and B3, and B4 to Bn, and each bag has a weight and a value. And Taro has a limited option that he can took those bags whose summation of all the weight of those bags will be less than or equal to W. So we have to maximize the value that Taro will take by picking some bags. So if so, it is a problem knapsack 2. But if you are solving knapsack 2, it's mean you have already solved knapsack 1. In knapsack 1, our DP state was here, it was index and it was weight, which calculate the maximum value, which we can take by having this weight. And one more thing, it is a 0 1 knapsack. It's mean we have to take a bag or not. It's mean we can't take half of bag. But here the range of index is from 1 to 10 square, and the range of weight, the maximum weight which can go is up to 10 ki power 9. So total number of DPS set will be 10 ki power 11, which is not feasible because simply we go off number of DP states, it will not pass. So here this code will give runtime error, and before giving runtime error, it will give memory error because 10 to power 11 DP state is not feasible. So we have to modify our DP state. Here DP index and value. So we will define that it is a maximum, it is a minimum, it is a minimum weight which require to get value V till that index. So is question so we can solve this question in two way, by recursion and by tabulation. So I will solve in both way, but firstly we will look at tabulation. So I will show you code. So here is the iterative way, and what I am doing. Firstly, we are taking input N and W. N is number of bags which we can take, and W is maximum weight uh, that we can take. That, here W is the sum of the weights that we can take. It can't reach beyond W. And weight value, here we are taking the weight and value of input, and then we are defining the DP state. It is a maximum. Mum, it is a maximum. The here the first time, like DP 102. Why 102? Because the maximum value of n is 100, so we are taking 102. And why 100,500? Because the maximum value of W, the maximum value of V is 1 less than 10 ki power cube. So 10 ki power cube into 10 square. Here 10 square is the here we are finding the maximum value which we can get. 10 power 3 into uh, 10 power square. Like each bag has a value of 10 power cube maximum. So 10 power 5. That's why here we are taking 100,500. Then we are defining our DP state, like we are initializing it with W plus 1. Why W plus 1? Because uh, we can also take infinity or int max, but W plus 1 is that DP state which is unreachable. Here uh, we are iterating from 0 to n, and then I think it's a wrong code. So the base case is DP0 and DP0 0. Why? DP0 0 equal to 0. Why? Because here to get the value of 0, we need 0 weight. So it's just a base case. Here we are defining it. For int I equal to 1 to I less than equal to n, I plus plus. Then for n j equal to 0, j is less than n, j is less than 100,500, j plus plus. So here we are taking the condition of dp of I of j equal to dp of I minus 1 of j. It is a condition of not take. Why not take? Here we will look on. Firstly, the condition of not take. dp of I of j equal to dp I minus 1 of j. Here we are thinking in the reverse direction, like it was I minus 1 and then I. So we are at here. So we are assuming that we have not take anything at this part. So we will move to I plus 1. So, but here, so what will be the value? So what will be the weight? Here we are not taking. So it's mean that the dpi minus 1 j equal to dpi of ij. Why? Because it defines it's a weight. it's also a weight. So weight is not changing and we are not taking at this place. So it's a condition of not take and this is the condition of take. dp of I j equal to minimum okay dp I minus 1 of I minus 1 j minus value of I minus 1 plus weight of I. So here we are I and our previous state was I minus 1. So dpi minus 1. So if we have took we have take this bag. So it means the earliest in the previous step in the previous index what was the value of weight? The value of weight will be dpi minus 1 and j minus value of value of I think it should be value of I and plus hmm, it was the weight of the last index. So our current weight adding will be addition of last will be addition of last state weight. So here we are going to I minus 1 dpi minus 1 of j minus value. So we will move from I equal to 1 to n. Why I equal to 1 to n? I equal to 1 to n because we are assuming that dp of 0 and 0 will always be 0. So here we are also moving j minus value of j minus 1. So we will take the condition here. So here we will take the condition. So we don't move to an unnecessary condition. J minus value of I minus 1 is greater than equal to 0. Why I minus 1? Because here we are going with one base indexing. So our original array was 0 base indexing. That's why I am using I minus 1. And dp I minus 1 or j minus value of I minus 1 plus weight I minus 1 is less than equal to W. So this state defines that we should not reach the unnecessary condition and unrequired or unusable condition because it will not add anything in our result. And after, which is the main part, what will be the answer? So here we are iterating for I equal to 0 to I is less than 100,500 I plus plus. What is 100,500? It is the maximum value of value which we can reach. So int answer equal to 0. So if dp n we have take all the packs. So dp of n, matlab we are at the actually it's n minus 1 if we have followed zero base indexing, but here we have followed one base indexing, so we have to write here dp of n and dp of n I is less than equal to W. Why? It is the minimum weight required to get the value of I. So answer equal to max of answer. And dp of n of I. So that will be our answer. So now look at the recursive way. Recursive way. So here we are defining dp ij equal to int max. We can also define w plus 1 because we will not reach there. Our main intention is to we always define the initial state of dpij such that it is not reachable. In most of the cases, it is minus 1 because minus 1 is not reachable in most of the questions. Uh, in the iterative code, we are getting answer uh, after in iterative code, we are getting answer by moving on some DP state. So here we are also doing same, but we are calling the function at every time. I think it is not correct code. This is correct code. So we are calling the function every time, but every time some DP state will be set. So you might be thinking that this function will call every time. So this should be give TLE because it will have some time complexity, and it is already 10 key power 1, 2, 3, 4, 5, 10 power 5. But it is not actually because function if index double equal to n, if value equal to 0, return 0, else return into max. If dp so here we are defining that is it reachable dp 0 of I is less than of w, or an answer equal to max of answer of I. For int I equal to 0, I less than 10500 plus n, I plus plus function 0, I weight value n, 0, I weight value n. So we are seeing that we are at the initial stage and the value of I. So we can reach at this value or not. If after taking all the bags, our value is 0, then we will return 0. And if not, we will return into max. Why into max? Because in that condition, we will not get this. So condition or not take index plus 1 and value will remain same. But we will take the weight of index plus function of index plus 1. Uh, we are adding the weight because we are taking that bag. So the weight of that bag is adding in our current answer. And then we are calling function of index plus 1 this. So it will return some, it will solve this question, value minus 1. You might be thinking that this will give TLE, but actually, at every call, some DB states are defining. So after some time, it will not reach there, and it will return answer in big of one after some time, because after some recursive code, and it will return dp of index of value. If it is not long max, then it will return. So it will drastically decrease the time complexity. So that is my recursive code. So thank you for all joining this session. So thank you for all. I hope you have understood this problem very well. Thank you for watching till end.